Today for my science experiment, I will be testing whether Coke and Mentos or sugar and Mentos makes a larger, faster reaction. First off, I'm going to start with the sugar and Coke, and I will be counting how long it takes and trying to measure how far up it goes. And last bottle of Coke, I only ended up having to use about half of the sugar that I had poured in. And I have 3/4 cup in each container. So we're gonna see how long it takes with the second one. So I had another almost instant reaction, and I did get a little bit more sugar in this time, but I still wasn't able to use all the sugar before I had a reaction. So this is attempt number 3 with sugar. I'm going to attempt to get the full cup in this time. And again, I didn't get the full cup in, but I did get a bigger reaction this time than I have with all the other attempts. Now I have used all the sugar and Coke, so I can move on to trying the Mentos and Coke. I have 4 Mentos for each attempt to see how high. So with 2 Mentos, I had an instant reaction. This is attempt number 2 with Mentos and Coke. Last time I didn't get all 4 Mentos in quick enough and it exploded, so this time I'm going to attempt to get all 4 in. Okay, so this is my 3rd attempt with Coke and Mentos. I have completed all the other attempts between sugar and Mentos. And so now I'm going to put the 4 in and see how high I can get it to go and how fast. Oh. What I learned from the entire experience overall was that the sugar did have a less of a reaction than what I originally planned on. In the original hypothesis, I said that the sugar would have the bigger reaction, but they all had an equal reaction time, they instantly had something happen, but the bigger reaction did come from the Mentos and Coke. I did have multiple over 2 feet, and one of the sugars cleared the porch, but I will say the Mentos did do the best with the Coke. There's a huge mess now, and all of my information and charting is going to be in the next video, which is going to be on the poster and my overall experience. So the overall purpose and question of the experiment was whether Mentos or sugar, when placed in Coke, would cause a larger or faster reaction. The hypothesis before I researched was that the sugar would cause a faster reaction and the Mentos would cause a larger reaction. My hypothesis after research was that the sugar would still cause the larger reaction due to the weight and texture of the sugar. The materials I used were sugar, Mentos, and Coke. I did not end up using plastic cups for the Coke itself. I did use it for the sugar though. The steps taken were only putting the sugar and Mentos in the Coke and then cleaning up the mess afterwards, because there really wasn't that many steps to my experiment. The control was the amount of Mentos and sugar used. The dependent variable was the height of the explosion, and the independent variable was the amount of Coke that I would use. This is my citation page. So this is the overall heights and time chart of the experiment. They all had the same time because they all reacted instantly as soon as I dropped the other materials in. But with the S's, that stands for sugar, and then M stands for Mentos. For my first drop with sugar, it was 1.5 feet. Sugar drop 2 was 2.5 feet. Sugar drop 3 was 3 1/4 foot. Mentos drop 1 was 4 feet. Mentos 2 cleared 7.5 feet. And my third drop cleared 5 feet. The conclusion to my experiment was that the Mentos ended up causing the largest reaction, although the time was equal for all of the ingredients, which was both sugar and Mentos. They both instantly exploded and had a very big mess. Many people assume that the Coke in Mentos causes an explosion by chemicals mixing. The truth is, the reaction isn't caused by chemicals at all. The reaction is a physical reaction called nucleation. When looking into the background of soda, all carbonated drinks are in a state of supersaturation. This means the soda is completely saturated in carbon dioxide. When a liquid is supersaturated, it generally can't hold any more of the saturation substance. When adding sugar to a glass of water and stirring constantly, it eventually starts sinking instead of dissolving. Then when you heat the water, it is able to dissolve more. The carbon dioxide is added to the water in a very similar way. The carbon is constantly trying to escape the soda, but as soon as you open up the bottle, the bubbles form, allowing a small escape. When placing an object into carbonated liquid, it causes bubbles to form on the object and rise. The reason is that the objects you place into your liquid aren't as smooth as they look. All objects have tiny bumps, grooves, and dents on them. Due to the roughness of the sweets and how fast they plummet into the liquid, it causes a reaction. If you drop a pack of Mentos into a bottle of Diet Coke, you get this huge fountain of spray and Diet Coke foaming out. This was a good project for my students to study because there was still some mystery to it, says Tonya Coffey, a physicist at Appalachian State University in Boone, North Carolina. In the beginning, it was thought that the reaction was caused by something having to do with caffeine, but Coffey and a team of students decided to test this out. When the team decided to test out different types of Cokes, they got the same reaction with every type, including Diet caffeine-free Coke. The team also measured pH levels before and after the experiment, and the acidity level never changed. This ruled out acid-based reactions and caffeine-based reactions. What the team came to realization was that the rough surfaces of the Mentos caused an encouragement to produce more bubbles. This is because the Mentos disrupted the polar attraction between water molecules, creating bubble growth. Water molecules like to be next to one another. So basically anything that you drop into the soda that disrupts the network of water molecules can act as a growth site for bubbles. And if you have a rough candy with a high ratio of surface area to the volume, and there's more places for the bubbles to go, Coffey told New Scientist. Due to the fact that the sugar and salt and sand all have the same effect as the Mentos, they also cause an eruption. The texture, surface tension, and rapidness of dropping into the liquid will cause the outcome to be relatively similar. So this is the overall poster. So the overall experiment itself was not hard. The inspiration behind this was in 6th grade we did an experiment, and mine was filling up a balloon with Coke and Mentos. So I wanted to see whether Mentos and Coke, or Mentos and sugar, would cause like more of a reaction, because when you make a slushie, in order to keep the ice smooth, you have to put sugar in the liquid, or else the ice gets all chunky and like doesn't like form into a slushie, right? And I put I put the Coke and the sugar in first the one time, and it started to like foam up. So that was kind of like the reason I wanted to see what would cause more of a reaction. There's not really much I have to say other than that. I kind of already said everything in the previous parts of the video. Yes, my hair is blue now. But yeah. And the way I measured how high it went was because I measured the stairs behind the Coke before I did the experiment. So I was able to kind of look back and see how high up on the stairs each one went. And then the one cleared the railing, which was, I think, second drop for Mentos, and that one went about 7.5 feet ish, and that was the max, like the tallest reaction. But anyways, that is my science experiment and poster.